Hey guys, and welcome to Functional Print Friday. So let's keep going on this timer base for this Hakko soldering iron. If you missed last week's video, go check that out. What we're doing is I want to build a base that this guy can sit on that has some basic electronics built into it so that if I forget to turn this guy off, and I do, it doesn't burn my house down. Because right now it has got just a dumb switch on the side that if this guy is on, this thing is heated up to 1,000 degrees, and while it's kind of safe in the base here, that is really hot. Something could fall on it. It could start a fire, and I don't like that. So where'd we leave off? Last week we did a test print of kind of getting close, narrowing in on the design. Had a couple issues. This guy didn't quite fit on here. Some of the parts didn't fit inside here. I screwed up my hole for where the cable gland was going to go through. Again, go back, check last week's video. There's a bunch of design work that is covered in that one. But this week, where we left off was, we did an updated version of the design, and I have now printed that. And I gotta say, I am pretty pleased with it. I think it's looking real good. So let me get you in a different view. I'll show you the details again in here, and we'll start figuring out how we're gonna get some parts to fit. The big changes we made were around where the supports were in here, basically limiting them, giving a little extra clearance for our timer board, designing our own strain relief from scratch back here, centering up the hole for the outlet, and we made some aesthetic changes to where the button goes in the front. So let's see how things fit. All right, so I've got everything dumped out onto a tray here, including the other 3D printed parts that we designed but hadn't yet printed. This is the bottom of this guy, as this is going to sit like this. The piece that was against the bed is actually our top, which is going to have the soldering iron sit down on it. So there's also some feet for this guy. Those are done in TPU. See how they fit. Perfect. That one was even tighter to put in. This one, it's not coming out on its own, but I would have liked it to be a little bit tighter. That one was just right. That one's nice and tight. The last one. Okay, so those are good. And this is PLA. These are TPU. I'm not going to put any glue on these. Gravity is going to hold these guys in place. And I designed them with, sort of some open rings in them just to give them a little more bite on whatever surface this sits on. So let's see. These holes line up, and these are going to be M4 screws, but these holes are the diameter of the hole is the same size hole the correct tap drill would make for an M4 by 0.7, but they're not actually tapped. So go grab the correct tap. We'll tap these holes. We'll try out the screws and make sure that everything is good to go with that. All right, here is the correct tap. So let's get these holes tapped. And I'm not going to put these on a base and line it up or anything like that. I mean, this is just to secure the bottom. As long as it's close to lined up, we're good. All right, all four of those are threaded. I blew them each out with the air compressor, so we should be able to test fit this now. Obviously, we're going to have to take it back off since we need to actually install all the components in there, but let's just make sure everything fits good. All right, that is all four in, and those fit perfectly. They threaded in really easy. When the bolt gets to the point where the knurling is inside the bore here on the cover itself, it rubs just a little bit, which is perfect because that'll stop them from backing out. Doesn't rub a lot, but just enough. You can actually kind of feel the knurling as you're turning it in. So, and they look really good. I was a little worried about coming all the way to the edge on these because we kept the shelf that this bottom cover Sits on fairly thin, but I think that looks good. Again, we're not actually going to see the bottom of it, since it's going to be sitting down like this, with this guy sitting on top of it. Yeah, I think that's going to work well. All right, so what is next? We probably don't want to put all the components in because it's going to be difficult to solder if they're all in there, but we can probably put some of them in. What I'm thinking is we should at least put the power cord in. That's going to be easier to do out here in the shop. I think it's going to be a bit tricky to feed that through our cable gland here and get that locked into place in the back. So let's get this cover off and see what we can install out here before we start doing our wiring. All right, so a perfect example of what we don't want to put in here yet is our timer board. We do want to make sure that this guy fits, and it does fit in there very nicely now with our minor modifications, and we can make sure our buttons are going to work. So our buttons just feed through. They are just sort of small little columns here that feed through the depth of the front of this guy. One more here somewhere. There it is. Then this guy is going to go here. That'll screw into place. We'll just use like a self-tapping screw there. We're not going to try and tap those holes. And when everything is lined up, we will see the display through the recess there, and these buttons will line up with the micro switches down here. So when right now they're just captured in there between the board and the side of the case, and when we push them down, they activate the micro switch. And the micro switch pushes them back up. Real simple design. But if we put this guy in place, if we screw this in place with the buttons here, there's no way we're ever going to be able to wire into these terminals. So we'll need to wire this all up and then screw this into place last. And there's no point in having the buttons in there yet either. This guy, we could probably put that in solder those terminals. I will wait. Might be easier to feed the wires sort of back through this hole, solder it outside, and then push it into place. This guy we could almost certainly push into place, just given how long these leads are, how much room we're going to have to work, and we don't need to solder anything down here because it's got leads already on it. Our momentary switch, yeah, we're definitely going to wait to put in. That's going to be a real pain to reach in there inside of those. We could if we had to. There's just no reason to fight with it. It's going to be a lot easier to solder it outside or to solder the leads on and then slip the leads through and put this into place. Here's the transformer that I got. We're still gonna have to test this guy. It is tiny, like this. I'm gonna put it on my pinky finger. So you can see it's really only about the same width as my pinky finger and really about the same length as just the last segment of my finger. It's tiny. But sure enough, it does say AC in on this side and VCC, so our positive and negative DC on this side. I mean, it looks like everything is there for this guy to work. I'm just impressed how small they can make this for what the current rating was on this guy. Oh, so is that everything? We have our power cord. Oh, this lighted switch. This switch has an LED in it. We can't just feed this guy 12 volts directly. It is a smaller voltage. I think it's like 3 or 5 volts, and we need to limit the current, so we're going to have to add a resistor there. This is a 2.2K ohm resistor. I think the spec sheet calls for 1K ohm or higher. I used a 2.2 the last time I used one of these switches for my UV curing chamber. Was very happy with it. We'll test it and make sure that it does look like it's going to be, a good amount of brightness. But, if anything, this guy should just last even longer if we're not glowing it quite as brightly. So this guy has 4 terminals. We've got a whole bunch of terminals on here. We've got this guy. We somehow have to have our on-off switch and our power in and our power out. It's going to be really difficult to show you what gets connected to what when I'm trying to solder it all together in this tiny little case. So I prepared the world's jankiest wiring diagram, and I'm going to try and step you through it first. So down here is our AC in. So this will be the other end of this wire. This will plug into the wall, and imagine this is that wire coming in. And I'm sure none of the naming conventions are on here correctly. I just, put some notes on here so that I could hopefully figure out what is going on to be able to explain it to you. So we have hot, neutral, and ground on the AC line. The only thing that ground is going to do is just go right over to the AC outlet so that the outlet itself is grounded as well. There's nothing in here that we're going to be grounding. Everything in here either has no way of grounding it or is only going to have low voltage DC on it. Our neutral is also going to go right over to the outlet, but it is also going to come up here to our AC-DC transformer because we need hot and neutral on the AC side to get DC out of this guy. The hot is just going to come up to our switch, and when I say our switch, since I know we have two, I mean this guy that is going to be on the side of our base that is going to switch our incoming AC. So that when this switch is off, nothing in this whole box has power. And not shown on this diagram, but I will probably add it, is we'll probably go ahead and just put an inline fuse between the AC in and this switch so that if anything goes horribly wrong in here, we'll limit the current that this guy can draw out of the outlet to only what we need to support for the soldering iron. I think that guy's 70 watts, so I'll do the math and figure out what the appropriate fuse is. But hot then coming out of the switch, one is going to go up here alongside the neutral to our AC-DC transformer, or our AC transformer with then rectifier on it built in and capacitors and everything you need on there to get a smooth, stable 12-volt DC out. And the other hot is going to go up to our timer board because remember, we're actually switching high voltage here. We're switching the AC for the soldering iron. The soldering iron is going to plug into the AC outlet here. This AC outlet right here. So our hot comes up here, and then when the relay is thrown on here, the hot travels back down out to the outlet. So there's actually two things that are preventing that hot from getting from the AC in to the AC out. That's our simple physical switch over here and the relay on the timer board. So now we get sort of to the low voltage side of the circuit here. Our transformer here and rectifier, we have DC 12 volts plus and minus. Our positive is going to come up to the positive in on the timer board. Our negative is going to go into the negative in on the timer board. Timer board also has a center screw for signal. Signal, what does that mean? Well, we need something to trigger the timer. So what this is looking for is anything up to the same 12 volts that we're feeding in on the positive side momentarily being fed into their signal terminal that tells this guy to go ahead and start the timer cycle. So it gets a little tricky up here because this is a lighted switch, but it's not that complex. What the switch is doing is just also sending that 12 volt DC into the signal input on the timer board when we push the button on the switch. Otherwise, there's no 12 volt DC going into that signal terminal. It looks complicated because we also need positive and negative up here for the light on this switch. And the positive side actually goes through that 2.2K ohm resistor first before we go to that positive terminal. We could essentially take that part out and just represent this as the 12 volt coming out of here. One goes directly into the DC input on the timer board. The other one just goes through a switch and then into the signal. But because we chose a light switch, it looks a bit more complex. It's really not that bad. Nice thing about this is because it's a lighted switch, we'll know if we've left this guy on. In addition to having the readout from the timer board, if this switch is on, the lighted switch will also be lit up. So I'll include a still frame of this at the end that is probably, I'll take a picture of it, include it as a still frame in the video, and maybe even link it from my site, fpfdesigns.com, so that if you want to print this out, you can. Hopefully it's not too hard to follow. Try to make it as easy as possible. So, all right, let me get everything packed up here. Well, no, before we start wiring, let's see if that strain relief is going to work out. Okay, let's see. So we're going to have to run the wire through here first. Then the strain relief is going to go on the wire, and then the whole thing, the wire and the strain relief together, will get pushed back. Take the wire out of the way here so you can see for now. It'll get pushed back through this hole until this larger section of the barrel on the strain relief is able to drop down into this gap down here. I don't know that that's going to work. I have not tried it yet. I know this guy is a fairly snug fit on the wire. We'll probably have to use some Windex to get this guy to slide on there well. What I don't know is if this is going to flex enough to drop down in here, particularly with the wire in it, but it's only one way to find out. All right, well, I managed to get it to feed on there that far, and then I remembered that the wire has to go through the hole first. So yeah, I guess let's do that over again. Man, that is a fight, but I think it's going to work. We're through here now, so I should be able to get some pliers or something to grip onto this wire and then pull from this. It's really hard to hold this down here in front of the camera with the tripod in the way. All right, I think that is going to work. And I'm going to make sure I fed plenty through, because we can always cut off the extra that we don't need. This power cord is plenty long enough. I think this guy's going to plug in like 10 inches from where it's going to sit. So. Now step 2 is getting this guy to feed through here enough to drop down in that gap. I may put some Windex on that part as well. It's certainly not going to hurt. I think it's going to go. Looks like it should be there. You know what, I see, so because it's at an angle, we're not quite clear of the bottom here. I'm going to see if I can kind of force that down over it. There we go. I was about to say that I might go and change the design for that to allow for some more room, but all you really need to do is just get in there with a flathead screwdriver and just push from the bottom of the TPU. It's flexible enough that just it compressed a little bit and it dropped right down in there. So now we're sitting on the curved part of the back of our block there. So all we should have to do is feed some zip ties through here, zip tie this guy down, and I think that worked out pretty well. Now let's see if I can move this wire. No, that guy's not going anywhere. So, perfect. I'm actually really happy with that. I will probably end up using this same cable inlet design for other projects. Not only does it give us sort of the gland through the case that in this case with TPU should even be watertight, not that we need that for this. But we also get the strain relief of the material because we taper that down. You can see how as we bend this cable, that TPU is taking the brunt of that force. So perfect. All right, now I think we are ready to take this down to my electronics workbench and start actually soldering everything up and connecting everything up the way that I had shown on the wiring diagram here. So let's go do that. All right, I think that's actually everything wired up in there. Before I screw this in place and figure out exactly where I want this transformer to sit, I think I'm going to try powering this guy up on the variac, so ramp up the voltage slowly and make sure that everything is indeed working. All right, I think I've got everything in frame, so if anything spontaneously combusts, we'll have it on video. So I'm going to very, very slowly up the voltage, and I'm watching my current consumption. Oh, that's a good sign. So I am going to ramp all the way up to 110. So I see our timer board's powered up, our LED is lit up on our switch, and the indicator light on our AC to DC converter is lit. So we don't have power here. If we hit the switch on the side, it should turn off. Yep, okay. So switch is in the off position, switch is in the on position, and if we hit this, the timer should start. I don't know what it's set at by default, but it should start, and this should power up. So here we go. And, oh, you know what? This might not even be on. Yep, there we go. Okay, so the timer is set for a really short period of time, but we can adjust that. Again, one more time, when I hit the switch, timer clicks, turns on. It's like it's set at 2 seconds right now. Yeah. Cool. All right, well, I think everything in here looks like it is working correctly. I'll ramp down our voltage, turn this guy off. Let's get everything back out to my bench in the garage, and we'll get this buttoned up. All right, back out here in the shop, I did do two things before I brought it out. One of them was I added some hot glue back here at the outlet. I found the plastic to be pretty brittle on the two little locking tabs here, and even though I sized the hole to their specifications, it still seemed when they bent far enough in to clear the hole that they weakened a little bit. So I thought, let me just back that up with some hot glue in there. I don't think it's really needed, but it's certainly not going to hurt. Obviously, when you're plugging something in, it's pushing against the face out here. It's when you're unplugging it that I think something could potentially shift in the future. So just seemed like a good idea. While I had the hot glue gun heated up, I also just put a dap back here towards the back of the enclosure, and then just pushed the circuit board down into it. I'm also going to get some zip ties and zip tie these wires coming up off of it to the lead coming off of the outlet, which will just further stabilize it. I don't think this guy is going anywhere anyway. Again, this thing's just going to live on my electronics bench, but it doesn't hurt to overdo it. The only thing I would change in the way that I wired this was I didn't leave much lead for the fuse. I ended up putting a 5 amp fuse in here. We could have gotten away with a 1 amp fuse for this guy. I did the math, and I think it came out to like 0.5 something amps that it's going to draw at the 70 watts. But I put I put a 5 amp fuse in, just thinking, I think the relay was rated at, I think, 10 amps. And based on the wire gauge that I use for all the AC circuitry, we'd be fine at 10 amps. And I just divided that in two and figured that I am definitely safe putting a 5 amp load on this. So in case I use this for anything in the future, like if I grab it for another project that I need to be able to just switch off with the timer, I'm safe up to 5 amps. If I forget and plug something in that is bigger than 5 amps, it'll blow this fuse. I can still get in here. There's still plenty of room to unscrew this and replace it, but I would have left myself more leads if I did it again. I tried to keep everything as short as possible because I was convinced I was going to run out of space in here. The reality is there's plenty of room. I mean, I could have 3 times the amount of wiring in here and still have plenty of space to work. So unfortunately, I did this as one of the first things. I've already cut the leads. I'm not going to go back and try and extend things. It's fine. I doubt I'm ever replacing this fuse. Just saying, if you're doing this, you can keep the leads for the fuse a little bit longer. So, All right, this has got to get screwed in the front. We got to put the buttons in. I think I have some tiny screws that will be good to mount this guy. These are, I think, 2.6 millimeter. They're just, the threads on here just, self-tap their way into that plastic. So let's see if we can get the timer board in the front mounted with these. I didn't think about it when I designed it, but the standoffs at the bottom of the case are probably going to be pretty difficult to get to for these screws. So that might be a bit tricky. We also got to put the buttons in here first. Oh, and all right, so the top ones went in no problem, and they're the ones that are supporting the force against these buttons anyway. But yeah, I think the bottom ones are going to be tricky. These were even a little bit tough to get in. See if I can keep it in frame here while I try and get these in. All right, I had to do that off camera. I ended up actually having to, I only got the original screws in part of the way and then had to back them out with a pair of pliers. I had to go with a slightly smaller screw and I did get those in. The heads did start to strip a little bit, but they are all the way in and that board is snugly in place. The top two went in no problem, and that's again where all the force is from these buttons anyway. So I'm not worried about it, but I will say that if I was gonna make another one of these, I would probably size these holes just a little bit bigger and then try and tap them for M3. I know it'd be a pain to spin a tap down there, but I think you could do it with a ratchet. And then you could use a socket head screw, and with one of these, you can turn at a much better angle than you can with a Phillips. These will work from, these will work from that angle, no problem. So that's the only change I would have made there. We've got these all tapped. Everything is now buttoned up, ready to go inside. So let's get the bottom on. All right, brought you down in close for this. This should be the last step. When we flip this guy over, it should be all ready to go. I'm gonna get them all in here before I tighten down. All right, let's get this plugged in. All right, power's up. See, this plugs in around the back, like so. Now, if we push the button, it turns on, but only for a couple of seconds. So, I gotta figure out how to program this guy. So that's 900. If that's in seconds, that would be 15 minutes. Yeah, that looks like it's counting down in seconds. So that should be good. 15 minutes, it doesn't, I'm not generally soldering for more than 15 minutes. Now that said, I think I was soldering for like 40 minutes to get this guy all together. But it's not a big deal to reach over and push that button. I believe you can set this up. I know this only has 3 digits on the display, but I think you can set this higher than 999 seconds. Let me look at the listing quick and see if I can remember how you do that. All right, I've been fiddling with it for a few minutes. So when you press the middle button, you can select the digit. And when you get to where no digit is flashing, you have the decimal point there. And if you hit it till you have no decimal point visible, that's number of seconds. So that would be 30 seconds if I started it. If you hit it until you have the decimal point all the way at the right, now you are in minutes. So now I have it set at 30 minutes. So if I hit this button, it'll turn on and it'll run for 30 minutes. That should be plenty long enough. I've been going back and forth between like 15, 30, 45, 60. I had it set at 60 and then I thought, how often am I really soldering something for 60 minutes? It's so rare that if I had to hit the button once to kick it on again, that's probably good. So now this guy will automatically shut off after 30 minutes. All right, that should give you a better view. You can see how it sits on there. The base is really not that much bigger than the actual base of the soldering iron base station. And the button is real easy to press. This is a pretty slippery surface here, and just the weight of the soldering iron is enough that when I push this button, it's not moving. So again, if I flip this off, everything turns off. I flip this back on. Our base station, or I should say our timer base, turns on, and it'll sit there at the 30. It doesn't start counting down. It's just saying that it is set at 30 minutes. And then when we push the button, soldering iron flips on, will heat up, and this guy will start counting down. And once it gets down to 0 minutes, the soldering iron will turn off. So really, really super happy with how that came out, and how the final form factor of it came out as well. Buttons are easy to press. It's easy to unplug, plug in. Switch is easy to operate on the side. Soldering iron stays on there, no problem. You can see that guy is not sliding around at all. It drops right in place. So yeah, really happy with that. Guys, as always, thanks for hanging out in the shop with me. I know this was a two-part build. If you enjoyed this, please hit that like button down there. I've learned a ton watching YouTube myself. If you learned something from watching this, I would really appreciate you taking a second to do that. This project took quite a while. I would have done it anyway, even if I wasn't recording it for the channel, but everything takes 3 times as long when you're recording it, and then add another double that for the amount of time it takes to edit it. So I really appreciate your likes, and if you really enjoyed this video, hit that subscribe button. I do stuff like this every Friday, whether it be a whole new from scratch device like this, or just improving something that I've already got, or an accessory for a tool out here in the shop or something around the house. And guys, if you do subscribe, I'll see you next Friday.